There we go. Okay. So this recording is going to be provided to you guys post-event with our session slides as well. We are going to have Q&A open during the event. Everyone will be muted though. If you could please use the Q&A separate chat, that would be great. We have our lovely GitLab folks helping out with our Q&A today, which I'll introduce in just a second, but our panelists who are helping with that Q&A section, we're only monitoring the Q&A section. So please ask your questions there and not in the general chat. Perfect. Okay. So I'm going to go ahead and introduce everybody. So the first person we have here is Logan Stucker. He is our demo architect extraordinaire who is going to be helping out on the back end today. He is based out of Denver, Colorado. We also have a really amazing group of solution architects. So our lead SAs are Rode Zahn, based out of Austin, Texas, and Yu Chen Shui, based out of Dallas, Texas. On the back end, helping out with our Q&A, like I mentioned before, we have JC Perez, based out of San Diego, California, and Sean Sherwood, based out of Cincinnati, Ohio. So just really quick to recap, this workshop does require that you have a gitlab.com account. Logan did go ahead and he pasted that link in case you don't have an account in our general chat. So if for some reason you don't have that account set up, please go ahead and use that link. This was set out as pre-work, so most of you should have done this already. But again, if not, please go ahead and just do that now. So quick recap. Please use the Q&A section for all questions. That's what we'll be monitoring, and that's where we'll answer all of your questions today. The session is being recorded, and the presentation and recording will be sent out via email post-event. Please check the chat for the pre-work links, and then you will have 48 hours to come back and complete the workshop. So that is all of our housekeeping, and I'm going to go ahead and turn it over to Rose now to take you through the agenda.
Sounds good. Thank you, Alexa. Good morning, good afternoon, everyone. Thank you so much for taking your time to join us today. And we are very happy to have you here. So with today's workshop agenda, and we are going to work on the lab environment setup, and then followed by 4 labs. We will also walk you through on how to transfer the workshop project into your own GitLab namespace if you would like to continue working on the project or keep the project for personal learning purposes. The format of the labs will be a brief presentation. We will go through some of the concepts and the terminologies, then the hands-on practice. As Alexa mentioned, if you have any questions related to the content, related to the labs, feel free to let us know. All right. So thank you so much for joining the workshop. Today, you're officially part of a brand new startup. That's exciting. And the startup is creating a public elite board for a hit new racing game called Tanuki Racing. So this groundbreaking new application has been developed and deployed in the beta trial stage. And however, the developers are lost on how to secure the application. And so as a new security specialist, so all of us on the AppSec team and helping the developer to deploy and deliver a new Tanuki Racing application securely. So as the new security specialist, we are tasked to use GitLab to enhance the application overall security. All right, so first part of the lab, we are going to work with you to set up the lab environment. As I briefly mentioned, the workshop agenda, and we're going to first work on the labs setup. And I believe Logan shared the link in the chat. Don't worry, we will walk you through the steps as well. And we are going to work on 4 labs together, shifting left, how to leverage GitLab to enable you shift left for software delivery, and how to parse the scan results. And we are going to have 2 labs on deep dive on like a SBOM, license compliance using GitLab. Lastly, how to configure and leverage GitLab for on-demand scans, audit events, and much more. And lastly, transfer project, as I mentioned, you can transfer the project into your own GitLab namespace. And lastly, we will wrap up the workshop. All right, so as one of the prerequisite, you do need to have a GitLab.com account. If you don't have one yet, feel free to use the link Logan shared, the sign up link, and to create an account on GitLab.com. So once we go through the lab warm up, the setup, you are going to leverage, basically we are going to bootstrap your lab environment, and those groups, you're going to have an isolated group, and those groups will be available until October 22nd, so more than 2 days. And you will have the option to transfer the project out for later when you're done the workshop. All right. So the first step for for setting up the lab environment, please go to the link in the chat. We post that again in the chat. Yeah, thank you, Logan. So go to the link and then use the code to redeem the workshop environment. So I will walk you through the steps as well. And I'm going to go to the same link, okay? So once you are on this page, you will see the landing page will show you the option to sign in with GitLab. I would like to pause here and to make sure everybody has a GitLab.com account. If you don't, feel free to go to the sign up page and create an account. If you have a GitLab account, let us know in the chat and say yes. And if you don't, and we can wait maybe a little bit longer to make sure everybody is on the same page, and then we can go ahead and get started with the lab environment setup. Yeah, and you got a 404. Okay. So feel free to work with our QAs and post the questions in the Q&A section, and we will work with you on the error. So Steve, if you can clarify if you're getting 404 error on the sign up page or the workshop redeem page, like auth login. So if everybody is on this page, and we're going to click on sign in with GitLab. All right, because I already have an account on GitLab.com, and that is my GitLab account name, the handle. So you will see the option, the box for you to provide or enter the redemption code. And then we are going to basically provide the code Logan shared in the chat. And once you're ready, click on submit code. All right, so once you are on this page, that means the redemption was successful. And what we need to do when you are on this page, we just need to open GitLab workspace. Then it will take you to the group we just created for the workshop project. All right. Let me know if the pace is too fast, or, and we can slow down if needed. All right. So once you click into the workspace from the redemption page, right, it will take you to the workshop project. you will see the Tanuki Racing Security and Compliance Workshop. Let me confirm, is everybody here? Are you getting errors? All right, so let's go back to the deck. So we did this. We entered the redemption code and we submitted the code. We also able to accessing the group from there. And now we should be here, right? The name might be different from the screenshot. The one we are seeing should be the Security and Compliance Workshop project. All right. So once we're there, so the most difficult part now is done. I know like we always run into some issues that some people might not have a GitLab.com account and run into 404 errors like Steve with the redemption code. So once we pass this part, the warm setup, we should be able to see the project in the group and also yeah, so it looks like Steve shared a link in the chat, GitLab.com. Let me click into that. And also feel free to work with our QAs on the issue, Steve. All right, so let's continue with the lab. So now we have the project in your group, right? We are going to leverage the issues for the lab instruction. So for this workshop, we have 4 labs, 4 issues. Each issue has very detailed steps for us to follow through, okay? So the first lab we are going to work on is leveraging GitLab to allow you to shift left. So I know sometimes people say, hey, shift left, what does that mean, right? It's like a loaded term. So I'm curious from the audience, what does the shift left mean to you? If you don't mind sharing, feel free to type your responses in the chat box and let us know. And as part of the lab 1, we will first take advantage of how GitLab enables customers and us to shift left and catch security mistakes and vulnerabilities at the merge request, right? Instead of like waiting until your application goes live in production a month later. And then when you find like the vulnerabilities is it takes time to remediate the vulnerability, to address the vulnerabilities, right? So we are leveraging GitLab as part of the lab 1 to shift left, to catch vulnerabilities early on in the SDLC instead of like once like after your application goes live in production. I see some responses in the chat. Okay, Steve, it works. Yeah, feel free to share your understanding of the shifting left. What does that mean to you? In the chat, and any feedback is welcome. All right. And what does the shifting left really mean, right? Imagine you created like a lovely sandcastle. I love go to beaches, and I have a little one, and like building sandcastle is his favorite activity at the beach. And so, but wait, like you did not notice like the waves are coming closer after you building the beautiful castles, right? And when the waves hit your castle, basically all the hard work, your castles gets washed away. So if only when you had to check the position before you build the castles, before you build the walls around the castles, right? And so we do need to build some like basically the boundaries, the walls around the castles to protect it from being washed away by the waves. So by shifting left, the goal is to find and address potential problems early on in the SDLC rather than like facing the consequences of not doing so later, right? And I also leveraged the AI dual chat and to help me understand, hey, what does the shift left mean in like a security context? And so as you can see here, I highlighted, it says a shift left in the security context means moving security testing and the practices only in the software development lifecycle, SDLC, rather than waiting until later stages or production. So the core idea of shifting left, right, is catch vulnerabilities early on, integrate security into SDLC, into your CI/CD pipelines, empower developers, and give developers the security feedback immediately so they can address the issues and understand what is introducing the vulnerabilities, how to address, remediate the vulnerabilities before they merge the code into the main or the default branch. And also the other core idea is reducing cost, right? Fixing vulnerabilities early is significantly cheaper than fixing them in production. All right. So this slide provides like a really high-level overview of a GitLab. I'm curious if anyone used the GitLab before or is using GitLab. If you don't mind, feel free to share your responses in the chat. I would like to know what tools you're using for source code management, for security scanning, and CI/CD. All right, let's continue. Feel free to post and share your responses. So this slide, as I mentioned, it provides like a super high level overview, right? GitLab is the most comprehensive DevSecOps platform, and it allows you to plan your work, manage your source code, so essentially the goal is to empower you and your teams to balance speed and security by automating software delivery and also securing your end-to-end software supply chain. Securing the governance and compliance are some of the important components of the platform. As you can see from the diagram here, the graph, you can use a GitLab to manage threat vectors, right? In your environment, secure your software supply chain, help with the compliance requirements. You also have a visibility into software development lifecycle, for example, value stream analytics, DORA metrics, how frequent you deploy, you release your applications, what's the mean time to recover if something goes wrong, right? All right. So why shifting left is important? I know we briefly talked about the core ideas, right? Well, remediating security security vulnerabilities is very expensive, especially in the later stage in your SDLC or even in production environments. So the earlier you catch the vulnerabilities, the easier, the cheaper they are. So I'm sure you have seen a lot of the security vulnerabilities in the news, like that result in significant amount of downtime and a cost, like a significant amount of cost to the organizations as well, right? Like a brand damage. For example, I know a few years there was a huge news on SolarWinds cyber attack, and that cost a lot of money for the organization, and also it took them a long time to recover the reputation damage as well. As you can see from the chart, right? And so this one really shows the idea of like how important, how critical is to have a shifting left in place in your environment. So if you detect any vulnerabilities early on, maybe in your user story or in your requirements, you can quickly address that. So in the coding as well. So this is the idea we are trying to introducing, right? So when developers work on like user stories and new features, before they merge the code into the production branch, right? That we are able to scan the code and surface the findings to the developers. So developers are able to get feedback right away and also act on it, right? They are able to understand, hey, it looks like my code is introducing this vulnerability. What does the vulnerability mean and how to address it? So they are able to act on it before they merge the changes into the production environment. So you are able to catch vulnerabilities early on before you integrate the code changes and testing the code changes and before releasing them into your production. So like as you can see here, when you catch vulnerabilities in production or in later stage of your SDLC, the amount of a cost is much higher. I believe it says 30 times higher. And also some other stats, as you can see from the slide, right? There is a 24 trillion annual cost of software bugs related to security vulnerabilities, and it costs like a 300 developer hours to address like vulnerabilities in the later stage in the SDLC. I hope that paints a picture like how important to have a shifting left methodology and the principle in software delivery. Feel free to stop me and post your feedback in the chat if I need to slow down a little bit. And so the other thing I want to talk through is shifting left. It doesn't really mean like you have to slow down your software development, right? And the GitLab provides a developer-centric experience by integrating security into your CI/CD workflows, and also enables a fast feedback loop and also close collaboration between dev team and AppSec team. And this one shows the total economic impact of a GitLab security. So based on an organization that is around like a 5,000 initial users growing at a rate of 25% of year over year, and with the, like annual revenue of a 60 billion, right? They are able to save like a 4.8 million, like a reclaiming the lost revenue from security incident. So basically this one tells the similar story from the previous slide. Is it really critical to catch vulnerabilities early on and address security concerns early on in your environment? Otherwise, it will have a huge negative economic impact on your organization. All right, so I would like to show you some of the views or dashboards you will be able to see. So this one shows like when you have security scans built into your CI/CD workflow, right? And from developers developers or DevOps engineer or AppSec team, they are able to see, they are able to visualize, hey, what security scans are built into my CI/CD pipeline. As you can see here, we have 5 stages in the pipeline: build, test, and with the test stage, we included a lot of security scans as part of the workflow. And so, as I mentioned, shifting left doesn't really mean you have to slow down, right? Your software development, and GitLab provides the platform for developers and the AppSec team to collaborate on and focus on the developer-centric experience by integrating security into your day-to-day CI/CD workflow, and enable, at the same time, enable faster feedback loop between developers and your security vulnerability management team. And so we are able to see like this slide basically shows that we are able to see the results and able to parse the results based on the security scans you included in your CI/CD workflows. And so this is one of the views into the security dashboard in GitLab. And we can see what projects, right, need our attention, and what is failing with the compliance center. You can clearly see, so it looks like, hey, the the status is failing, and you can click into that and see more details on that. So it provides governance, and it also help you to achieve your compliance requirements. All right, so this one is kind of like a more like an overview look of your security dashboard using GitLab. And so using GitLab platform enables visibility into your value streams. Some of the key metrics using the value streams, right? You can see what's the risk score and what's the lead time for your organization to deploy release like a new version of the application? What's the cycle time from working on the user story and turn user stories into actual like features in your application? However, GitLab offers much more than just like securing your code, right? GitLab offers the capability for you to secure container registry to protect your build images and packages as well. As you can see here, this is a setting you can configure in your GitLab environment. So this allows you to address the security and the control challenges in managing like a container images, right? And making sure the images are updated and they are from the trusted sources. And this feature also allows you to have a control over like a push and pull interactions with your images. And as you can see here, you can specify what's the minimum access level for pushing an image into the registry. All right. So the presentation part is done. Now the fun part starts. So we are going to go to the project we just redeemed, go to the group, and as we mentioned, we have 4 issues to work through for the workshop today. The first one we're going to work on is called shifting left. So if you are able to go to the group, and the landing page within the group, you will see this. You will see the Tanuki Racing Security and the Compliance Workshop. Click into that. So this is the main project we are going to be working on for the workshop. And as I mentioned, all the instructions are documented using GitLab issues. And the first one we're going to work on is called shifting left. So feel free to click into that. You can expand the window as well. So this is the issue as part of the lab 1 we're going to work on. And feel free to click on read more because it has a lot of information. And so as part of this hands-on exercise, step 0, as I mentioned, the issue provides the hands-on instructions for our first lab. And to start, you feel free to click on assign yourself. So we're going to assign the issue to ourselves. And so it is suggested you keep the issue open in the separate tab. So what I usually do, it depends on the browser you're using. For today's workshop, I'm going to use Chrome. And so what I'm going to do, I have 2 separate windows already created. I'm going to copy this link. Basically, the link will take me to the issue. And I have a different window over here. And I'm going to paste over here. So this one is going to be the issue. So what I'm trying to do here, I'm going to put the project side to side with the instruction. So it's easier for us to follow. But if you prefer, you might have multiple screens, windows, you can do that as well. Whatever works best for you. So for this lab, we are going to go through the shifting left issue, go through all the steps. All right, so we are working on step 1, setting up our scanners. The goal of the workshop for the first part of the workshop is to build in security scans into your CI/CD workflow. So whenever developers make new changes to your code base, right? Once they commit the change, it will trigger a merge request, will trigger a pipeline run. And because we are building in the security scans into the pipeline, so whenever we trigger a new pipeline, because like a new commits, a new merge request, it will make sure the security scans are part of the workflow. And the developers are able to see the new vulnerabilities they are introducing and then take action on that. All right, so going back to step one, first, make sure you're on the main page of the project. Make sure you are on this main page for the Tanuki Racing Security and Compliance Workshop. So this is the landing page for the project. And as I mentioned, you can open the instructions in a separate tab or different screen. And I'm doing the different window and put them side by side. And so once that is ready, and we are going to use the left-hand navigation on the main project page, this page, okay? We are going to go to the build. So we separate actually something I would like to call out. We revamped our UI. So if you worked with a GitLab before, you might see a lot of UI changes. I love the new UI. It is like user-friendly, very intuitive. And also for the lab one, as we mentioned, we are going to go to the left-hand navigation. This part, we didn't change anything. So we separate the features, the use cases based on the stages. So the first part, we're working on the pipeline, right? So we are going to the build stage and then click on following the step 2, go to the pipeline editor. So we are going to the pipeline editor. And here, so basically what we are looking at is the current setup of the pipeline against the main branch. You will see in the pipeline, we declared 3 stages: build, test, release. And build basically just build the image, right? For the application, let's take a look at the test stage. For the test stage right now, for the main branch, we are not doing a lot. So basically just like a unit test, and that's pretty much it. We don't have any security scans, security testing as part of the testing stage. And then the last stage basically is the semantic versioning for the release. All right. Yeah, so the pipeline does very little in terms of the security scanning and only has like a very simple unit test defined. And so we are going to change, and we're going to build a few scanners, security scanning jobs into the pipeline. So we are going to click on, now we're moving on to step 4, okay? Use the left-hand navigation menu and click through build and pipeline. So we're going through, so the pipeline editor, so basically to allow you quickly view your existing pipeline. But we are going to kick off a new pipeline. So what you need to do, go to the same stage, build, and go to pipeline. As you can see here, no pipelines in this project yet. So we are going to click on new pipeline. And we are going to just run the pipeline against main. We don't need to change anything, just click on new pipeline. So this will kick off a new pipeline. So this one, what we see here, right? Basically, it's the same as what we saw in the pipeline configurations. 3 stages: build, unit test, linting, and then a semantic versioning. It doesn't have a security scans built in to the CI/CD pipeline. All right. And so the purpose of this step to just show you before we enable shift left, what the pipeline looks like. The next step we are going to do, we're working on step 5. We are going back to the main project. And then go to, actually you could go directly into the group. So step 5, we are going to create a new project. This project is for configuring your security scanner configurations, basically. And so from here, this is the landing page of your group. So you're at the group level, and we are going to click on new project. All right. And we are not doing anything fancy here. So we're going to just click on create a blank project, okay? And we are going to name the project as, you can copy paste that, Tanuki Racing Scanner Pipeline. And let's see if we need to change anything. Leave all other settings as is, and then just click on create a project. So we're not changing anything. All right, so this is a new project we created. So you might be wondering why we're creating a new project, right? I would like to walk you through this. So for this workshop, we are going to have 3 projects. The main one is like once you redeem the using the invitation code, that is the main workshop project. It is called the Tanuki Racing Security and Compliance Workshop Project. And this contains houses all the lab instructions. So the ultimate goal is to enforce security scans on the main project. So the project we just created manually is a Tanuki Racing Scanner Pipeline project. What does it do, right? Is like an empty project. It doesn't have a lot of information, doesn't have like an application code in the project. The only thing this project does, it will include scanner templates we are going to configure as part of the lab. We're going to also pick and choose what scanners you would like to include as part of the scanner pipeline, and also the configurations, the setup, the settings. All right, so as part of the lab 2, I think maybe the latter part of lab 1, we are going to also create Tanuki Racing Security and Compliance Workshop Security Policy Project. So when you enforce any security policies for the main project, it will automatically create the policy project. So this policy project, the purpose is basically it helps us to enforce certain security scans using policies. So we can incorporate different like security policies, like a policy execution and configurations, like MR approval policy and scan execution policy, pipeline execution policy as part of the same project. So basically, we are using policy as code to enforce the defined selected scans for your main project. I hope that explains why we're creating the project a little bit. So let's go back to the step. We just created a blank project here, right? And we are going to, this project is blank, as I said, it only has the README file. So we are going to do, we are going to add a pipeline for this project. So go to the build stage and then click on pipeline editor. And then once you're on this page, click on configure pipeline. You will see some, like this is like an example of a pipeline file. So it has a lot of dummy jobs in the pipeline. So you can just like remove it. You don't need to use it at all. We are going to have a specific pipeline for this project. So just remove what the default pipeline editor has. And then we are going to copy paste what this part has into the pipeline. How's the pace is too fast? Are you following? Any questions? Feel free to provide feedback in the chat. If we need to slow down, we can slow down. Pace is good. Thank you for confirming, David. Appreciate it. All right. Perfect. So we just copy paste the pipeline configurations to the new project pipeline, right? So let's take a look at this pipeline configuration. What does it do? So we included an image and a service. So basically, we are using that to build the Docker image, and also after that, we are going to, as you can see here, pipeline scanning. But before I go to the detailed jobs, I would like to show you the stages we have. We have 3 stages for this pipeline: build, test, and also post jobs, the post stage as well. And with the workflows, so this is where you can configure the rules, right? When to trigger this pipeline. And so when the CI pipeline source is a merge request event, it will not run. It says whenever. And then if you just commit the changes using the tag to the tag specific tag or the protected commit ref, the default branch, it will trigger the pipeline. And this is the main part I would like to show. We are using GitLab security scanners components and templates to quickly allow you to build in security scans into your CI/CD pipelines for your projects. So as you can see here, we are including multiple templates components in this pipeline. This one is for SaaS scanning, static application security testing against your application code. It will detect any known vulnerabilities in your source code. And as part of the SaaS scanning, the SaaS scanner with the GitLab, we recently released advanced SaaS. This scanner allows us to have less false positives, more accurate results. So we are enabling advanced SaaS for this scanner pipeline. And we are also including secret detection, make sure that the new code we are adding to the code base is not including like secrets or in plain text. So we are going to perform like a secret detection against the pipeline and make sure developers are not including any secrets in the code base. And we're also performing container scanning because this is the application we are building, the Ruby, the Tanuki Racing is containerized application. We can run container scanning as part of the CI/CD pipeline. We are also doing dependency scanning. So it's very flexible. It depends on your security requirements, compliance requirements. You can include more security, like templates, components. You can even build out your own custom components or templates based on your specific requirements. We are also including IAC, infrastructure as code, SaaS scanning job template in the pipeline as well. And so once we go through all the security scans, we are also adding a post job. It's called upload SBOM. So we are going to upload the SBOM after the pipeline, after the scanning jobs are done. I hope that provides a little bit kind of like information on the pipeline, how we are configuring the scanners as part of the pipeline. And so we went through the pipeline, explained why we added the include. So what we can do to visualize the full configuration. By looking at this configuration, the pipeline is not very complex, right? Because we are leveraging templates and components already built by GitLab. So what we can do here, we can visualize the templates we included, the jobs we specified as part of the pipeline. You will see as part of the testing stage, it has a lot of jobs related to SAS scanning. It depends on your application language you are using. It will pick the right scanner to perform the security scans. And we can also click on the full configuration. So using this, so basically it will show all the components, all the templates configurations we are including into your pipeline configuration. So this one is much longer, as you can see here, has a lot of configurations. I highly recommend leveraging the GitLab provided components or templates to quickly allow you to enable security scans in your environment. All right, so going back to the edit page, we are going to commit the change. I'm going to just commit the changes. So now the scanner pipeline project, which is still like an empty project, but we added a GitLab pipeline into the project. The pipeline includes multiple scanners and the specific configurations we would like to have. All right, so we are done with step one. Moving on to step two, enforcing pipeline compliance. So from here, we are going to go back to the main project. So this one is like the scanner pipeline project, right? So go back to the group, click on the group, and click into the main project, the security and compliance workshop. And from here, we have, because we already defined our scanner pipeline, and now what we want to do, we want to ensure like this pipeline, the project pipeline, when we run it, we want to inject the scanner pipeline into this project pipeline. So what we are going to do, go to the hamburger icon on top and go to secure and policy. So what we are doing here, we are going to create a policy and leveraging the scanner pipeline we created and inject the pipeline into our project pipeline. So every time when developer commits anything to your main project, it will trigger the defined security scan jobs to run against your project. So we're going to click on policies. And from here, we're going to create a new policy. Click on new policy. And as you can see here, we have different types of policies, right? And the first one we're going to work on like all the policies for this lab. The first one we are going to add is a pipeline execution policy. So click on that. And provide a name is arbitrary name, but make sure you are able to identify what type of policy is and what's the purpose. So I'm going to just, let's say, workshop, pipeline, execution policy. With the description is optional, so feel free to add a description. So what else we need to update? We're going to leave inject as selected. All right, so there are two options. You can inject the scanner pipeline into your project pipeline. And the other option is override. So if you want to just override entire project pipeline, you can do that. So, but we are only injecting like a security scan jobs into the project pipeline. So we stay with inject, and then we can select where we are going to use the scanner pipeline, where the scanner pipeline house basically resides. So we are going to find the scanner pipeline, make sure it's the one you have. It looks like we have multiple here. So what I can do, make sure I'm linking my own scanner pipeline. Let's see. So is AP3Y, okay. All right, so looks like that one is mine. So make sure you are linking the correct one. And so our scanner pipeline configuration is in the GitLab, the CI YAML file, right? So we are going to just specify the file name. And here, all right. And with the file reference is a default branch because we committed the pipeline to the default branch. And we can leave that as is. What else do we need to change? Let's see. Select project, choose okay, we did that. Once done, click on create a new project with the new policy. Okay, so from here, we're going to click on create a new project with the new policy. So basically, we're configuring a new policy for the main project we have. Once we click on that, it created a new project. As you can see here, this is the security policy project for our main project. And I'm going to click on merge, but typically in real life, a real environment, you will need someone else from your AppSec team to review the changes and proof it and merge it. But for the workshop purposes, I'm going to just click on merge. So basically, we are defining some of the scanners using policy as code. It create a policy project. It has our policy configurations in the project. All right. And so we did that. Now we are going back to the main project. Okay. So what you can do, you just click on the group on top. Now we have 3 projects, right? This one is the main one. Now click into the security and the compliance workshop. The purpose of using like a policy project, right? Right now we're studying the policy project at the project level, but you can also have a policy project at the subgroup level, even like a top level group, right? So by doing that as a multi project approach, you can apply the policy and enforce a policy on multiple projects and the subgroups, allow you to maintain better access controls and also easier for implementation as well. All right, so now we are in the main project. Lastly, what we're going to do, we're going to create a new branch. All right, so go to the hamburger icon and go to code, because we're going to create a new branch, and click into the branches. And from here, we're going to create a new branch. The new branch name is called secure pipeline. You can copy paste or type it out, and it's against the main branch. So I'm going to click on that. All right. And we are done with the step 5. So make sure it's based off main. Yeah. All right. So another fun activity. I know I showed you a little bit like using GitLab Duo to explain what is shifting left, right? And feel free to leverage GitLab Duo, because in your lab environment, you have access to GitLab Duo Enterprise, the full suite, all the capabilities of GitLab AI solution. And one thing we can do, so for example, on the UI, right? Right after your icon, you will see the dual chat icon. And feel free to click on that. And you can ask any questions related to GitLab. So I'm going to just ask a really high level question and say, hey, please walk me through this project. The cool thing is dual agentic chat has the full context of the project. As you can see here, the reasoning process, right, is going through the listing out the repository file, the gem file from the project and the tree and everything. It's going through the files we have in this project. And now it's going through the main application files to understand the architectural setup, the structure. So once it's done, it will provide you very detailed explanation how the project works. As you can see here, project overview. This is a Ruby-based web application. And the cool thing is about it, it also identified this is a workshop project for training purposes. And the core application structure, the technology stack we're using, the application components we're using, database schema. So this is just one of the many things you can do with GitLab Duo. So feel free to play around and ask questions. So for example, if you are new to GitLab, right? And you can ask GitLab and say, hey, what's the difference between merge request and pull request, right? What does a merge request mean? If you are new to GitLab, feel free to ask questions using GitLab Duo chat. And let's try out this question. What security features does GitLab have? So with this, it's still using my existing session. So you can start a new session as well. So if the questions are not related and you don't want to hallucinate the AI model, so you can start a new session and say, hey, what security features does GitLab have? Other things you can do, I know some of the pipeline files are pretty complex and using a lot of specific syntax. If you are new to GitLab like a CI/CD pipelines, you can use a GitLab Duo to explain the pipelines to you and say, hey, what's the purpose of include in the pipeline, right? What does the workflow work in the pipeline? So you can leverage GitLab Duo for basically everything related to GitLab. And in the future, if you're interested in learning more, we also have like a GitLab Duo workshop, and we'll walk you through other user cases of GitLab Duo. But for today, it's more like a documentation, explaining existing code. So feel free to leverage that throughout the workshop. So as you can see here, let's see. We have a vulnerability management, security governance and compliance using security policies, compliance frameworks, the different scanners we support. I use it on daily basis. Like the agentic chat is life-changing. Yeah, so it's not just like for work related, for my personal project, I have been using Duo Chat as well. All right, so that is step 3. Let us know if you are not seeing GitLab Duo Chat. You should have access to it as part of the lab environment. We have enabled GitLab Duo for everybody. Moving on to step 4, creating the merge request. We created a new branch, right? And so there are multiple ways you can create a new merge request against like the new branch we created. As you can see here is the shortcut. You can click on create a merge request from here, but you can also go here, go to the code because it's related to the source code, the branching, and the merge request related to the code base. So we can click on merge request as well. So we are going to follow the instructions from here. Go to the code and go to merge request, then click on new create a merge request, new merge request. So in the source branch is already detected the branch we created. Let's see, source. All right. Make sure you pick the correct the source branch and also the target branch. So from here in the source branch section, select the secure pipeline. Secure, did I name it wrong? How about that? I'm missing E in the branch name. All right. So then the target branch is going to be made. All right. And once you're ready, click on compare branches and continue. So this will create a new merge request comparing the source branch and the target branch, right? It doesn't have anything because we just like create a new branch. It doesn't have like a code or changes in the new branch. I can basically sign the merge request to myself. And one thing, remember, like with the merge request, we need to configure. So scroll down to merge option. I think, yeah. So merge option, make sure you uncheck this one. So basically, once we merge the merge request, we are still keeping the source branch. The source branch will not be deleted. And so once you're ready, click on create merge request. All right. It doesn't have any changes, as you can see here, commits 0 and no pipelines. So what we're going to do with this, we're going to make some changes to the code base. We're going to use the web IDE. There are multiple ways you can interact with the branch. You can directly use the web IDE as a built-in IDE based on Visual Studio Code. And you can also check out the branch, like work with the code locally. So I'm going to use the web IDE. It's the easiest way. So with this, we are going to make a change. We're on step 3 here. And so open IDE, navigate to this folder, this file, okay? Go to lib and go to Tanuki Racing and the app.rb file. And then we are changing line 45. Find line 45 is right here. So basically we are just changing the title, right? And feel free to copy paste that, or you can just like change it directly, modify the existing file. All right, so now we made it like a tiny change to the code base, changing, updating the title. And what we are going to do, we are going to commit the change. So from the web IDE, you will see once you make a change, you will see the source control will show the changes you made, right? And we're going to commit the change, title update in the app.rb file. All right, then we are going to click on commit and push. You can just manually navigate back to the MR we created, or just click on here. It will take you to the same page. Because the change we made was against this merge request, and it will kick off, as you can see here, kicked off the new pipelines. This is the MR view. Developers will be spending a lot of time on this part. So whenever they make changes, they will be working with the merge request. And with the merge request view, it provides all the information related to the changes, right? And you can see the overview page, you can see the commits. That is the change we just made 46 seconds ago. The pipelines that we kicked off, the actual change, the diff, you can see the details here. Is everybody on the same page here? Any questions? Do I need to slow down or I need to speed up? right? Yeah, so once we commit it, you missed the merge part. Okay. So if you are in the IDE, right, and you modify the title here and commit the change, go to the source control and push the change. So once you do that, you will see a shortcut kind of like on the bottom of the screen. It will say go to MR. You can do that, but if you miss that, don't sweat. You can always go to your project, right? You can go to your project if you are on the main page. If you need to locate the MR, you can go to code and go to the merge request. And you will see all the merge requests related to your project. And this is the one we were on, the merge request is also here. I hope that answers your question. All right, so what we did here, let's see. The pipeline is still running. Let's click into the pipeline and see what it does, okay? And so the step 5 right here, you should see a pipeline kickoff. If you click the hyperlink we just did, will bring you to the pipeline view where you can see all the various jobs that we added to our main pipeline through using the pipeline execution policy. Let's take a look at it. Voila. So as you can see here, right? Previously, the first step of the lab, we click into the default pipeline. We only saw the unit test linting, but now we are injecting additional security jobs into your like the main project pipeline. So we now have a dependency scanning, SAS scanning, IAC scanning, secret detection, and in your project pipeline as part of the workflow. So whenever your developers commit any changes, those jobs will always be injected into the project pipeline. So this one would take a little bit time to go through all the security scanning jobs. So feel free to step away if you're waiting on the pipeline to complete. You can take bio break or refill your water, tea, coffee, and we will be back on, let's see, step 5 conclusion. And so basically we are pretty much done with lab 1. And after the break, we are going to move on to lab 2. Marco, I hope that answered your question. Were you able to catch up with the merge part? Do you have any follow-up questions on that? Sounds good. Yeah, let us know if you have any other questions. We are a little bit behind, so with the break, let us know if you are back, and we will continue with lab 2. So as you can see here, now the pipeline looks like my pipeline passed. And as part of the small change I made, right, to the code base, and we included the additional security scan jobs as part of the workflow and detected, looks like 31 new potential vulnerabilities. So this integration provides a single pane of glass view to developers. They can clearly see, oh, it looks like the changes I introduced have vulnerabilities, and I need to work on addressing them before like someone goes into the MR and approve it, right? So that wraps up lab 1. Let's move on to lab 2. I hope everybody is back. Let us know if you're ready, and we are going to continue with lab 2. Actually, a quick plug for GitLab Duo. As I mentioned, if you are interested in learning more, we have a lot of documentation, tutorials, and also AI-specific workshop. But this one shows like a high level, like a user cases of a Duo, GitLab Duo. GitLab Duo is AI solution that GitLab provides, and it can be leveraged throughout the entire SDLC, not just for code assistance. As you can see here, you can leverage Duo for documentation. You can leverage Duo for generating issue description to accelerate writing like user stories, requirements, or bug reports. You can also use GitLab Duo for vulnerability explanation and also resolution. Like a pipeline troubleshooting. If you run into like a pipeline errors, you can leverage Duo to help you troubleshoot by looking at the pipeline logs and identify the potential solution for that. So there are a lot of things you can do. Yeah, feel free to check out our documentation, and also feel free to sign up for our future AI workshops. So with the lab 2, and you might be wondering, all right, so now I have the security scans incorporated into my project pipeline, and how to understand the vulnerabilities and how to address them, remediate the vulnerabilities, right? So for lab 2, we are going to work on understanding the result, parsing the results. All right, so we are on lab 2. Now our merge request, the pipeline has completed, and we also noticed that there are quite few vulnerabilities in our main project, right? And we know it works as we want to merge it into the main as well. Like when we merge anything into the default branch, it will kick off the merge request, so which means it will inject the security jobs into the workflow. So we are going to, with the lab 2, take a deeper look into the scans and also the findings of the scans, as well as like create any policies. As I mentioned, right now we only worked on pipeline execution policy. So next we are going to work on the rest of the policies, like a merge request approval policy and the scan execution policy, to help us prevent security breaches in the future. So you are able to block any commits and merges when vulnerabilities are detected. Right now, it doesn't block, right? So it doesn't provide a visibility into the vulnerabilities. But with other security policies GitLab provides, you are able to block the merges. All right, so this one provides like a quick high-level overview of GitLab scanning capabilities. Let's first look at like overarching capabilities. And so after you detect the vulnerabilities, right? So we are also providing the capabilities for enterprises to better understand your vulnerabilities, manage your vulnerabilities, like including viewing the vulnerabilities, the triage, and it will help you understand the trend, the track, and resolve vulnerabilities. And we also have a dependency management. It allows you to track dependencies used in your projects across different subgroups or groups. And we also have a security and the license approval. We are going to work on that as part of the lab 2. So we are going to leverage merge request approval policy. Basically, that will block the merge request and require approval from your specific AppSec team or vulnerability management team to approve the merge request. And we also have a scan enforcement. So you can require scans to be run as part of a pipeline or on a schedule, or like against a specific branch. There are multiple policies to help you to achieve the requirements. And we also have a pre-building scanning. which means like you can enable secret detection, SAS scanning, and ISC scanning, dependency scanning, license compliance before you push out the code, right? So as part of the merge request approval workflow, it will, as long as you have those enabled or enforced, you are able to see the pre-building scanning findings and results. Post-building scanning, you can also incorporate like a container scanning into your workflow, and also like a DAST, dynamic application security testing against your web applications, like API security against your web application or any applications you're using, and the fast testing. So the multiple user cases around the security and compliance you can leverage GitLab for. All right. So after you detect all the vulnerabilities and you see the vulnerabilities in your project, right? The next step is how to fix them, how to remediate, triage those vulnerabilities, right? So this slide talks about prioritizing fixes. And we are going to leverage EPSS score. I'm not sure it's just me, but like when I look at EPSS, for some reason I keep thinking about ESPP, like it EPSS, or what was like an employee stock purchase plan or something. And this one, EPSS, stands for Exploit Prediction Scoring System. So this is a scoring system to help us understand the uh, the the criticality of your vulnerability, right? So you can, based on the score system, you can make decisions based on which vulnerability is most likely to be abused, right, in your system. And additionally with the GitLab, there's another policy called a vulnerability management policy. So basically, if you have from your previous pipeline runs, right, it detected a lot of vulnerabilities, but then developers might address them in the subsequent pipeline runs. They are no longer detected. With a vulnerability management policy, it will auto-resolve those vulnerabilities. Instead of waiting on your AppSec team, go into the vulnerability management dashboard and mark them as resolved. Using the management policy, it allows you to basically automatically resolve those the vulnerabilities if they are no longer detected in your environment. All right, I know we have been talking about policies a lot, and the few policies I would like to highlight. The first one is a merge request approval policy. So basically allows you to take action based on the scan results. So for example, when a developer commits a new change, like the one we just went through, right? We saw like vulnerabilities in our code base. And with the merge request approval policy, basically it will block the merge request, and it will, there are two options, right? As a developer, you can go back and modify your code and make sure you are not including any vulnerabilities. And the other option is maybe it's false positive or not as critical, and you need to get the changes into the environment. You might be able to get exception approval from your AppSec team. So that will allow you to collaborate with your AppSec team on the changes. And the other one is a scan execution policy. So if you want to perform security scans on the specified schedule, or like against a specific branch, like a production, so for example, you want to perform scheduled scan, like for secret detection, right, against your production, or even like any branches, right? So you can leverage like a scan execution policy to achieve that. All right, I know that's a lot. So with the policy management, you're able to, with the GitLab, you're able to define the rules, the policies, to make sure and to help you to adhere to like a compliance requirements and multiple the user cases or the features you can leverage. And with the GitLab, you can implement granular user roles and permissions, I know separation of duties is critical, right? You don't want to give people who are the committer make the changes and prove their own changes, right? So you are able to put the guardrails in place and make sure the merge request requires multiple people to approve it, and make sure the committer is not the approver. So that's something you can implement with the GitLab access controls. You have different roles. You can integrate with your IDP and map the IDP AD groups with different roles in GitLab. You can also configure compliance settings with the policies. Like you can specify like the merge request approval rules, who can approve the merge requests. And you can also pick and choose what branches you would like to protect, right? So with the protected branches, you are able to prevent unauthorized modifications to the specific branches and environment. So there are a lot of things you can do around compliance and also policy management. And the other one is a compliance framework. So compliance framework basically is to enable you apply policy, enforce policies at a scale. And so you might have like a specific compliance you need to adhere to, like a PCI, right? And PII, for example. And so compliance framework is more like a label, and you can associate the compliance framework with the specific like policies, specific controls you need to have in place with the all the scan configurations. And then you can apply the policy to the compliance framework. And so basically all the project has the specific compliance framework label will have the policies enabled and enforced. All right, so we are going to move on to the hands-on section for Lab 2. And similarly, we are going back to the main project, okay? Go back to the main project. We are back here. And all the instructions are documented in the issue. So you make sure, actually, like we already done, finished the shift left, you can mark as closed. But for the lab 2, we're going to work on the issue 2. So expand that. All right, let's click on that. We can directly go into step 1, merge request security result. So this is the merge request we created, right? We committed a new change, and we have the pipeline execution policy in place. And so it says use the left navigation menu to click back into merge request, then click the merge request we created earlier. So if you're already on this page, you will see the merge request and all the details. If you're not here, you can go here and click on merge request, okay? And so step 2, right below the approval section, let's see. We can see the code quality, different, let's expand that. So you will see different scans we have, and the license compliance, the security scanning templates we included, and now generated the security reports, right? And unique to this branch, to this merge request, and those reports are generated with each commit. So we can always know if we have introduced a new bug or new vulnerability before it's deployed out. And as you can see here, we can go through, let's see, click into one, let's click into that. I'm going to, okay. Once you click into the hyperlink, right, it will walk you through what the vulnerability is about. It has a description and the severity of the vulnerability, the status of the vulnerability, and the tool we used to detect the vulnerability. This one is SAS, and actually is IAC. So it's using the KICS, the SAS scanner specifically, and it also shows you where in the file, right, introduced the vulnerability. So This is the hyperlink for the location, the identifiers. And from here, you can also, like, for example, as an AppSec engineer specialist, I say, oh, wow, this is a critical vulnerability, and developers need to address it before we merge anything. So I could create an issue from here. And so basically it will create a new issue related to this, it create it. And then you can sign the issue to the developer who made the change, right? And it will basically notify the developer to work on, act on the vulnerability. All right. So now we are on step 3. Take some time to expand each report and look through the results. Okay. All right, we did that. Move on to step 4. From the view, we can see exactly where is occurred in the code. We did that as well. We created issue and assigned to the developer to address the vulnerability. So next, we are going to scroll down and merge our code. All right, so this one, we are just using the pipeline execution policy. So it's not like a really preventing people from merging the changes. So we are going to scroll down to this. It looks like it's not letting me to merge because the merge request right now is still marked as a draft. So make sure you remove that. And if you don't see the merge button and refresh the page. And once you see here, we are going to merge the changes into the main branch. All right, so we merged the change into the main branch, right? And so what we can do here, we are going to take a look at the pipeline, because when you merge anything into the main branch, it will kick off the pipeline as well. So the pipeline is a part of the build stage. So click into build and click into pipeline. So you will see a new pipeline here. And this pipeline will take a little bit of time as well. It has a lot more jobs. As you can see here, like initially we had 2 testing job, linting and the other one was let me see, unit test, right? But we now injected additional security scanning jobs into the workflow. So this one would take a little bit of time. So once the pipeline is complete, you will see those results being published to the security dashboard, the vulnerability dashboard. Is everyone on this page? Are you able to see the pipeline? Any questions on this? All right, let me refresh. Feel free to step away to refill your coffee, tea, or water, whatever you are drinking. And since we are waiting, and we can, let's see, I'm going to leverage a Duo to help me to say, hey, please walk me through the pipeline. That's the way it does. All right. Let's see. Nice. So it provides an overview of the pipeline and separate them into the stages. The build is pretty straightforward with the test. As you can see here, it includes the processes. That is for the unit test and the component and the release stage. Additional variables you can leverage. Looks like the pipeline is almost done. Yeah, we will speed up step 2 a little bit. So basically we're just like using the dashboard to help us understand the vulnerabilities in our application. All right. I'm curious if the results are there yet, or we still need to wait for the pipeline to complete. Yeah. Let's wait a little bit. It's almost done. Is everyone seeing the pipeline here? Nice. Thank you for confirming, Marco. I appreciate it. I think mine is almost done. The last 2 jobs are usually really quick. Okay, still running the semantic versioning. Just curious, right? I'm using the same window, this session. What does semantic versioning do? Feel free to play around with GitLab Duo. Nice. So I provided a response. Semantic versioning in the pipeline automatically manages version numbers and the releases based on the commit message. Very cool. All right, it's almost done. Okay, as you can see here, those 2 jobs passed with a warning. So what we can do, like we can leverage GitLab Duo as well. So you will see the troubleshoot option. This is a dual capability to help you troubleshoot errors in your pipeline. So you can quickly just click on troubleshoot, and the GitLab Duo will go through the logs in the pipeline and to help you identify the root cause of the failure. But this one is not blocking our pipeline. It's just like I think the syntax or access issue. But in the future, if you have access to GitLab Duo, you can leverage it for troubleshooting pipelines. Just wanted to show that. I think my pipeline is complete. I hope yours is complete as well. So once you have the pipeline complete and what we need to do, we're working on step 2. We will quickly go through this step, and you will see, go to the secure and security dashboard. Okay. Now you see, right? It has data because we complete the pipeline against the main, and it shows like how many the security vulnerabilities we have. You can expand, you can adjust the the time as well. So what we are going to take a look at is a vulnerability report. Dang, looks like we introduced quite a lot of vulnerabilities into the application. And so as an AppSec specialist, don't be overwhelmed by looking at all the vulnerabilities in your application. But we can use different capabilities in the dashboard to help us better understand the vulnerabilities and help us to troubleshoot as well. Okay, Marco is almost done. Perfect. Yeah. So once you're done, you can go to the security, secure and the vulnerability report. We are on, let's see, step 3. Well, here we can see the full report from here. Let's click into the filter bar, the option here. We are going to select scanner and the SAST, and then, okay. So from here, you are able to select scanner to filter the result, basically. And we are going to select advanced SAST. And once you select that, just click it elsewhere, use a mouse, or like using the magnifying glass, it will show the option as well. So we are able to filter the vulnerabilities based on the scanner, right? You are able to specify which scanner you would like to use, and we can click into any of the vulnerabilities. So for example, use of a weak hash. Okay. So from here, inside the vulnerability, and we can look through the information it provided, similarly to the other view we saw, right? It provides the description, the background, where the vulnerability was introduced in, the severity, the project, what scanner we used. And yeah, so feel free to spend a minute or two on this. But other thing I want to show you, like as AppSec specialist, right? Our job is not just like looking through the vulnerability, but we can also take actions on the vulnerability. So if you think, hey, this one is not like a medium severity, I think is low. So as long as you have access, the permission to do so, you can edit the vulnerability. So for example, you can change the status. Right now is a need triage. After you're looking through this, you say, hey, I triage. You can change the status. You can change the severity as well. So there are a lot of things you can do here. You can also, if it's a true positive, is indeed a vulnerability, and you would like developers to work on it, right? Address the vulnerability. You can create issues from here. All right. And the other thing I would like to show you is the dual user case as well. And what you can do here, you see the option explain or resolve with AI. So first, as like maybe someone is new to AppSec, right? And then don't have the full understanding of the vulnerability, I can leverage like a duo to explain the vulnerability to me. So you can do that. And so maybe even developers, when they write a code and introduce a vulnerability and they don't understand the terminology or what the vulnerability is about, and they can use a GitLab Duo to do to explain the vulnerability. It has all the details and how to fix the vulnerability. It provides like a potential solution for that as well. And then after you have a better understanding of the vulnerability, you would like to resolve, right? And we can resolve with AI. So basically, Duo will create a new merge request and include the proposed solution to remediate the vulnerability. So this will create a new merge request that fixes our vulnerability. As you can see here, it created a merge request that is trying to merge into main, and you can also look at the description, right? It says AI generated fix and all the details, the summary, and once it's done, you will see the commits. You will see the changes here too. So we updating the SHA. Instead of using SHA-1, we're using SHA-256, which is more secure. All right, that is step 2. Move on to step 3, tailoring results to reduce noise. So going back to the vulnerability dashboard, right? As we saw, we introduced quite a bit of vulnerabilities into the application. And so how to reduce the noise? So like go to the repository and okay, we are going to follow the instructions. Step 1, go to code, go to repository, and go to the GitLab folder. So this is where you can add a custom rules, GitLab related configurations in the folder. So we are going to set up a custom security scanning configuration specifically to this project. So what we are going to do, so inside the .GitLab folder, well, we are here, right? We're going to create a new file. We're on step 3. The new file named SAS rule set. Okay, so from here, feel free to click on Web IDE. We are going to leverage the Web IDE to make changes. All right. All right, so we're going into the folder, .gitlab, and then we are going to create a new file. So feel free to copy paste the file name or just type it as rule set Tom. Okay. And now we're going to copy paste the rules we would like to include for this project. Looks like we are adding a custom rule set for the IAC scanner and specifically for the S3 bucket vulnerability. And we include the type and also the value here. All right, so once you added the file and added the content, we are going to commit the change and make sure you add a commit message here, okay? And commit. We're committing against the main, so just continue. So what are we doing here? Let's go back to here and go to, now we kicked off the new pipeline, right? And because we added a new change, and the change will basically add a few exceptions related to the KICS scanner. Those basically not really applicable to the application. So we are going to exclude those vulnerabilities. So they will no longer as like marked as a need triage from the dashboard. So let's go back to the secure vulnerability report. The pipeline will take a little bit of time to complete all the steps. So what we're going to do after the pipeline complete, right? And right now, if we, let's see, just curious, like I'm going to select the scanner and the one we included was called a KICS scanner, right? So you will see the quite few vulnerabilities related to that. And we added a custom rule set and to exclude those vulnerabilities. So once the pipeline completes, we'll see some of the vulnerabilities will be marked as resolved. So I know we're a little behind, so I will continue with step 4. Once the pipeline completes, we can go back and validate that. Let us know if the pace is too fast. All right. As I mentioned, we are going to work on implementing other policies as well, right? We only worked on like a pipeline execution policy. Next, we're going to add additional policy into the project. So in step 4, we next want to navigate back to the vulnerability report by clicking through secure. Okay, we are already here, and set the scanner to secret detection. All right, I'm going to just unselect everything and then select scanner detection. It's not listed. Yeah, it's not listed the scanner here. And so what we are trying to do here, so we are going to implement merge request approval policy, and we are going to introduce like adding a secret into the code base, and the merge request approval policy will block the merge because we're including a secret. All right, so we are on step 2. So prevent this from ever happening in the future, we are going to set up a new policy to run on all future merge requests. And so for our user case, leaked tokens or secrets are easy mistakes. Absolutely. So oftentimes when you see like cyber attack news, right, is oftentimes related to secrets. And I know like people go through the repos in GitHub and to find like AWS secret key, access key, and they use that to do mining. Yeah, so it's really critical to make sure you don't introduce secret or API tokens into your code base. So we are going to create a new policy, secure. So we go back to make sure you are in the main project. Go to policy, and we're going to create a new policy here. The policy we're going to add is a merge request approval policy. So basically, we'll block the merge request when you are introducing any known vulnerabilities into the code changes, and give it a name. Let's see. I'm not like really creative, so I'm going to follow the same pattern. Merge request approval policy. Feel free to add a description. And because we're applying the policy at the project level, so we like, you don't have to do anything here, but if you are creating the policy at the subgroup level, you are able to pick and choose which project, which group, or which compliance framework you would like to apply the policy to. So what we need to change policy, okay. Add a name, and under the rules section, we want to select a security scan, all right? Not a license scan, so we are scanning secret, so it's a part of the security scan. And for the win, okay. And the scanner, and we are going to select secret detection. So you can like unselect all and then select the secret detection. And then against all scanners to be secret detection, ensure all protected branches. Okay, no exceptions. All right, that should be good. The two main changes is security scan, secret detection, all protected branches. And leave those as is. And the next section we would like to change is approval. All right. And so we are going to choose individual users as the choose approval type. You can do group. So if you have a group set up in your GitLab environment, you can do that. But for the workshop, we're going to just assign individual users as approver. So make sure select a user. I'm going to enter. It's going to be Logan. All right. And also, this is important. Like, make sure you click on advanced, okay? We are going to uncheck this one. What we're doing here is not recommended for production environment, for real environment. But for the workshop, we don't want to wait on Logan in order to merge anything. So you can force pushing and into your code base. All right. So anything else we need to change? Let's see. I think that's it. So once you're ready, go ahead and click on this one, configure with merge request. It took us to the same security policy project. As I mentioned, this is like a centralized security policy project to basically using policy as code, and you can configure all the security policies related to for your main project. And from here, we're going to click on merge. All right, so we updated the security policy. Now we're going back to our main project. This one, security and compliance workshop. All right, so move on to step 5. So our new secret detection policy will now be enforced with every commit. However, approval mistakes happen. So what we are going to do, we're going to set up additional scan execution policy to check for secrets that were mistakenly approved daily. So it's more like you can use this scan execution policy to kind of like a schedule scans against your code base or specific branch. So we are going to add one more security policy, okay? Go back to your main project because all the policies we created were at the project level. Go to secure and go to policies. And then we're going to add another policy. This time we are leveraging scan execution policy. So scan workshop, okay. Let's see what else we need to change. All right, configuration section. Okay, we want to select, you can customize it. Like if you click on this, you can pick and choose which is applicable to your environment. And for this one, we're going to select the template. Make sure you select the template. And let's see what else we need to do. In the scan execution strategy section, we want to select the merge request security. Okay. The default one is a merge request security. So you can just leave it as is. And this is where you can select which security scan to execute. Looks like the default one is a secret detection as well. So you can leave it as is. And lastly, we're going to just configure with a merge request. So you can use a UI, but there's the YAML configuration option as well. So if you prefer and familiar with the YAML, you can just use update that directly. So we are going to configure with the merge request. And merge it. So we updated the security policy project and added another policy. And so we are going to add another policy. I know we briefly talked about what it's about, right? So for this one, go back to your main project again, because we're configuring all the policies for this project. And then go to secure policy and click on new policy. And we are working on the last one, vulnerability management policy. Click on that. And give it a name. Let's see what configurations we need to select. Add a name, scroll down to the rules section, okay. Currently, most of our dependencies are coming from the dependency scanning. That's right. So we are going to, instead of selecting all the scanners, we're going to select the dependency scanning. All right, and what else? Next, we will change the all severity levels to critical and high, which makes sense because you might not have the bandwidth to like look through or triage all the vulnerabilities, right? And we want to focus on critical and high at the moment. So we are going to select those two. All right, so we are going to, I think we are ready to create this security policy. We're going to create a configure with merge request. So basically, it's pushing the change to the security policy project. So we're going to merge it. We're almost done with lab 2. All right, and now we are going back to the main workshop project again. And this is the exciting part because we are going to see the secret detection in action. And this is the last part of lab 2. And so we want to see our scan result policy and working in action for security detection. So from this main project, we're going to make another change to the code base. Click on the web IDE. I'm going to close that out. I have multiple windows. All right. And then we are going to find the file. It's called CF sample scripts and EKS YAML. Okay, it is a CF sample script and EKS. Make sure this is the file you're looking at. We are going to add a fake AWS token into the file and to see if the secret detection scanner is able to detect it. And we are going to update, let's see, line 6. Okay, so what you can do is just copy paste from the instruction, like what I'm doing right now, and find the line 6 is here. So basically, we just update this part. Okay, and it has a fake AWS key ID here, and that's it. That's the only change we're making. And so once you are done, click on the source control. Don't click on here yet. So for this one, we're doing slightly different. So we are going to adding, let's see, secret detection test. Instead of pushing that against the main branch, we are going to create a new branch. Okay, click on the arrow and select create a new branch and commit, and then enter. All right, so we created a new branch, and you can click on the shortcut from here, like create MR. So basically, we're trying to merge the new branch into main, and we'll create a merge request. And the other thing, like what you can do, you can summarize the code change using Duo. So let's see, let me do that quickly. And you can assign to yourself, see, it provides a pretty detailed summary on what changes we made. All right, so from here, click on create a merge request. All right, so we did that, we did this. Oh, actually, like with the merge request, right? Something we need to do. So you can, if you haven't done that, I missed it. So you can click on the merge request. It allows you to change. Let's see, uncheck that. Okay, and also after scheduled date, this one merge can start. We're going to select after scheduled date. And you can use the calendar icon, and we're going to select 2 days after scheduled day, 2 days out. Okay, so it's up to you. You can select the Saturday or next Monday. So I'm going to set that and save the changes. So still, one of the pipelines is still running. We can click into that, see the details. It's going through all the security scan jobs as part of the pipeline. You can go back to the MR. Let's see. I lost my MR, but no worries. You can always go back to the merge request. And the one we are working on is the new one. So as you can see here, looks like we detected the secret, and it shows the AWS access token, right? Because we added the key, the token into the file. So it got detected, and now it's asking for approval in order to merge the request. And we assigned Logan as the approver. So we need to get approval from Logan in order to merge the changes into your code base, which means you are shifting left, right? And by using the security policies, a different security policy in place, you are able to catch vulnerabilities early on. This will take a little bit of time to go through the rest of the security scanning jobs, but the point is, with this secret detection, we enabled scan execution policy, and we also have a merge request approval policy in place. Basically, it blocks a merge request and it requests someone who has the permissions to approve the merge request, like the vulnerability, maybe making an exception or for some of the scenarios, like a specific situation, you might need to do that. But oftentimes, like developers will need to address the vulnerability and make sure he or she is not including like a plain text, secret, or API key or token in the code base. So that wraps up step lab 2. I hope everyone was able to follow. And for next, I'm going to turn over to Yichen to continue with lab 3.
Thanks, Rose. Appreciate you taking through us lab 1 and 2. And I'm going to go ahead and start up lab 3 in the interest of time. I will go through some slide decks very briefly, but I'm going to kind of breeze through those. If anyone objects, let me know, but I'm guessing probably not too many objections to going through the slide decks fast. All right, let's see if I can get the right Chrome browser. So that's the toughest part. I think I've got it. And where is the share? All right. So Rose just took you through static analysis, software composition analysis, setting up some, sorry, give me 1 second. Let me just silence my phone real quick. I apologize for this. There we go. Okay, cool. Rose took you all through setting up static analysis, software composition analysis, and secrets detection, along with the policies that will make sure those scan types run. What I'm going to talk about a little bit is an extension of software composition analysis, the SBOM or software bill of materials, and how it pertains to open source license compliance. We'll spend most of our time in the lab, but I did want to just level set a little bit. Rose mentioned some high profile breaches that have hit the newswire pretty hard over the last few years. And some of them would be like SolarWinds, Log4j, or the big Las Vegas ransomware breach from a few years ago, which prompted a wave of legislation in the USA and across the globe to provide a software bill of materials. In fact, in 2021, the White House here in the USA mandated that any agency delivering software to a federal body must provide an SBOM. So as far as SBOMs, there's a number of formats out there. The two prevalent ones are Cyclone DX, which is what we support in GitLab today. I think the exact specification, by the way, is Cyclone DX 1.6, but don't quote me on that. Um, and it is a very lightweight standard that is broadly consumed by many, many tools, right? It supports a large number of change management and vulnerability management workflows. The other popular standard is SPDX. That one's favored by a lot of legal teams. It contains a lot of copyright information, and that is something that GitLab is working on adding support for. Also, SolarWinds kind of drives the topic of verifiable binaries or pipeline provenance, right? And I do want to make a brief mention that GitLab supports SLSA 1 compliance, meaning it provides a tamper-proof attestation that the pipeline was, had high integrity and that the provenance of the pipeline is reliable. We are working on adding the additional levels of SLSA compliance. There are 4 in total. All right, that's very brief introduction. We'll go ahead and zip into the workshop here. I also wanted to mention a couple small format differences between my audio video setup and Rose's. Rose has this nice side-by-side browser. I don't. I'm on a single screen, so I apologize. You're going to have to follow me as I jump back and forth between these two browser tabs. Also, my nomenclature is kind of terrible. You'll see what I mean in a second, okay, with regard to the policies. So hopefully y'all can bear with me. All right, let's go ahead and launch right in. I want to leave some time for live Q&A. I actually see some familiar names in the audience today, so I want to thank everybody for attending. I know it's quite late in the night for some of the folks here. So first of all, where are we starting from? Well, I'm in the list of issues, our instructions, and I've picked number 3. Go ahead and load that up. And we're going to go down to actually step 1. Oops, I missed a step, didn't I? I need to assign the issue to myself. There we go. All right. So we're going to review and download our SBOM report. The scans that Rose had you all enable earlier, software composition analysis, they've produced an SBOM that's available right within GitLab. We'll go ahead and have a look at it. So this is the last merge request that Rose had up. Remember, we're waiting for Logan Stucker to approve this one if he did deem it okay to merge. So from this interface, I'm going to go back to our group, my group, I should say, that houses the 3 projects that you all have set up thus far. And I'm going to go into the Tanuki Racing Security and Compliance Workshop project that houses our code. So how to get to the SBOM? Go to Secure, Dependency List, and you'll see a list of the actual dependencies along with associated licenses and any vulnerabilities that may be associated with that particular dependency. There's a couple ways you can sort this list, right? Severity is the way I've got it sorted right now. Another popular way would be to sort by the packager, i.e., what is the package manager, right? Here I've got APKs, a number of them. These would be like your kind of OS level dependencies. But if I go through the SBOM, I would see that eventually there's going to be some application level dependencies, like the ones you see here that are called out in the gem file. All right. So be aware that there are a number of ways you can interact with these. But what's key is step number 3. This is exportable. Okay, so what format? Well, let's go up to the export button. JSON, CSV, and Cyclone DX, which is also JSON, but it's formatted to a particular Cyclone DX specification. Right? This is probably by far the most popular export because there are folks who use any number of change management systems out there to process the SBOMs. By the way, GitLab itself can process third-party SBOMs too. So the SBOMs can kind of leave GitLab and enter GitLab depending on what your need is. All right. If you do want to export that and try feeding it into your change management system, please feel free to do so. I will call out there is some GitLab specific schema. So if you run into hiccups doing that, please do feel free to give us a email or a call, and we'd be happy to assist you. Okay, big topic in recent years has been license compliance, right? When I got started in the software business in the year 1998, we were largely concerned with technical vulnerabilities, not so much open source licensing. Over the years, it's become apparent that technical vulnerabilities are important to deal with, largely why we're here today, but open source licensing that is infectious and can trigger obligations to, for example, open source an organization's own code bases can actually doom a company overnight. Um, it deals far more damage when that situation arises, and that's been proven in, frankly, courts via case law now. Okay, so one of the common questions from legal teams or GRC teams is going to be, well, that's great that we see the technical defects or vulnerabilities, but what kind of open source licensing considerations do we have? We just looked at one of them, right? We can kind of search by the package manager, but what might be more interesting is the example pointed out in number 2. What if we are concerned about the GPL family of licenses, in particular LGPL 3.0? That's a lesser GNU public license 3.0, which comes with DRM protections. So that's a pretty heavy one for legal teams to consider. How would we make a policy to be informed when a LGPL 3.0 license is potentially going to infect our code base? Well, we're going to use a merge request approval policy, a concept that Rose already introduced you all to. And we're going to do something that's a different way to implement this policy. Rose took you through the UI-based wizard, where you're able to design a policy via combo boxes. What if you prefer to code that in YAML? Well, let's go ahead and do that. So for step 4, let's go ahead and, I'm really good at clicking buttons, okay, and being lazy. So let's be lazy together and click this YAML code and put it on our clipboard. You could probably guess what's going to happen next because you already did it once with Rose, but let's go ahead and create that merge request approval policy. All right, I'll scroll down just so you can see what we're going to do. The policy, by the way, is in the YAML, okay? So that's what we're going to copy it. So go ahead and follow the steps or follow along on my screen if you wish. I'm going to go to policies. All right, here's some wrong nomenclature is really horrible. Rose had those nice names for her policies. Mine just have awesome prepended to every single one. So let's make one that actually has a meaningful name, okay? Go ahead and click New Policy, go to Merge Request Approval Policy, select a new one, and License Policy. All right, first decent name from my side. We're going to go at the top instead of, sorry, I've got some Zoom stuff in the way. Let me move out of the way. Okay, we're going to click on YAML mode. See, we're in rule mode right now. If we toggle to YAML mode, we can actually write the policy by code, right? Because after all, these are versioned, these are auditable. So I'm just going to remove everything and paste in what's on my clipboard. Okay, and that's really it. And I'm going to configure that with a merge request, as you all have done before. All right. Just give that a moment and let you all know where we are. So we have actually created a policy, right? And now the next few steps are basically merge in the policy, right? So let's go ahead and do that. Give it a quick refresh. It's good practice, as Rose mentioned earlier. All right, and we'll go ahead and merge that in. So what's going to happen here is, remember how when we had a secret in the merge request, it prompted Logan Stucker, our reviewer, for approval? It will do that very same thing if we do find LGPL 3.0. Okay, we should be able to see that momentarily. Let's go ahead and move on with the lab. This was a short one, right? We've created our licensing policy. Now let's go ahead and have a look at this in action. I will call a timeout after the next lab. It is a very short one. Before we get there, obligatory break from our sponsors, i.e. the slide deck. All right, let's talk through what we're going to do in the next section. The final lap. Okay. I like to think of this as if you all eat any Hawaiian cuisine, like a poo-poo platter, kind of a variety of things that we didn't necessarily have the time to address in depth, but wanted to let you all be aware are present in the product. Okay, so kind of a sampler or appetizer as well, if you wish. So, first, a little bit of a preface, right? As a reminder of why these additional appetizers matter. Well, a lot of it has to do with the software industry being hyper competitive. And one point of competition is how fast we get our releases out to customers. Um, Also, as we're probably all aware, the application layer is a common target of malicious actors and is the source of many breaches. And breaches are costing more and more to remediate. That's not just a technical thing, by the way. A lot of that is just news of a breach. It travels through social media, notifications, and the PR damage is that much greater. Rose already covered one of the ways we can prioritize defects found a little bit better, and that was EPSS, right? Unlike Rose, I don't have an ESPP, so um, uh, but I do want to point out the importance of EPSS, right? The EPSS score, it is a score from 0 to 100. It's represented as a decimal, and it gives an estimate of, hey, there's a finding. How likely is this finding, this vulnerability, actually going to be exploited? How will it actually result in a breach within the next 30-day window? The KEV score, I'll briefly mention as well. And these, by the way, apply to the output from software composition analysis. Okay, so they help you determine your risk coming from open source usage. Is the KEV score, the K or KEV score? This is a binary, yes or no, and it says, has this vulnerability actually been exploited in the wild already? Between these two, there is no magic wand to prioritize necessarily. It's all going to be contextual to your organization and the project, right? But they should at least help you cut down and say, hey, I've got a whole bunch of findings. Which ones are the highest threat? Because they are being actively exploited or they are expected to be exploited. All right. Dynamic analysis or DAST, dynamic analysis was kind of all we had when I got started. And it's still an important tool, right? It really says, hey, this is where design time meets runtime. And we want to find actual vulnerabilities that can bite during runtime. We'll go through an exercise with a simple DAST scan, but I'll call out for now that there are two types of DAST scans offered by GitLab. Both of them are browser-based. They utilize the Chrome browser to load your web app, but one of them is integrated into the CI pipeline. The other is on demand. It's what we used to call kind of point and shoot DAST scans. We'll go through a quick and easy on-demand scan, but do know that these can be automated in either of those places, the CI system or on demand. We do have education offerings as well, by the way. Secure Flag, Code Warrior, and Contra are the ones that are embedded in the product. Do be aware that some of these require a fee, okay, but they are accessible inside the GitLab user interface. We'll have a look at that as well, so you know where to find it. Finally, audit events. This is a huge topic, but basically, when someone does something within GitLab, like configures permissions for access to a group, that is recorded and that is visible to security personnel. We have documentation that calls out all the audit events, and we will get our eyes on some that have been generated during our session today in just a moment. All right, let's go ahead and go through the final lab before we go to Q&A. All right, you all can do the right thing and close the issue. I'm going to be a little bit lazy, the thing I'm good at, and just rock on with number 4. All right, so bring lab number 4 up. Sign myself. Let's go through the on-demand scan. Excuse me. Okay, so we're not actually going to run this. You can run it if you want. I'm not going to, but we're going to pick a target, right? And of course, we don't want to go and attack like google.com or anything like that. So we're going to use our old friend example.logout for, oops, did I actually just open that? I didn't mean to do that. All right, let's go ahead and just put that on my clipboard, save me a little typing. So the on-demand scan, it comprises of two parts, all right? There's a scanner profile and a site profile. Scanner profile says, how does the scanner behave? And the site profile says, what is the endpoint that we are going to scan or attack or test, whatever terminology y'all like to use. So we're going to go ahead and configure an on-demand scan that comprises of those two ingredients. Okay, so that URL that I've got highlighted, example.com, is on my clipboard at this point. And let's go ahead and configure on-demand scan. Make sure you are back in your, should navigate back to the group. And make sure you are back in the Tanuki Racing Security and Compliance Workshop project, because in the last exercise, we modified the policy and GitLab probably took you to the security policy project. Okay, so we're going to go into the Tanuki Racing Security and Compliance Workshop project. All righty, and we're going to go to Secure on-demand scans. We're going to click New Scan. I'm going to see my horrible nomenclature come back in action. So I'm just going to call the scan. Remember, this is for the entire on-demand scan that comprises of the site profile and a scanner profile. Okay, so I'm going to just say my workshop on-demand scan. All right, the description, we can leave that empty for now. Ideally, you would have one. All right, but let's move down to scanner profile. All right. We're going to put select scanner profile. We don't have one, so let's hit the new scanner profile button. Scanner profile name, y'all can probably guess it, my scanner profile. All right, give it a more meaningful name if you wish. And we're going to keep everything a default. One key thing is we are only setting up a passive scan. Right? Passive scan does not actively attack the target. So do us a favor and leave it to passive. Let's not attack example.com. Okay, so we'll go ahead and save off that scanner profile. And next up is that site profile. Let's define the endpoint that we actually want to analyze. We'll hit the select site profile button under the site profile section. Put new site profile, profile name, my site profile. All right. The target URL, let's go ahead and just put example.com. Now, excluded URLs are typically things like logout pages, things that you don't actually want to scan. So we'll go ahead and mock that up by saying we don't want to scan example.com/logout. Okay, request headers. I'm going to go back to my exercises, and I'm going to copy step 5, the text from step 5, I should say. And we're going to put in some request headers so that the target that we're testing knows this is simply a test. Okay. You probably want something more meaningful in real life, but this will be good enough for our example. Okay. Finally, we're going to enable authentication. And let me just go back. Step 6. We'll take the URL for the authentication URL along with this username of root and password of password1234, right? Obviously, just kind of dummy values to fill the space. So authentication URL is that login URL, username, and then password 1234. All right. I'll briefly mention that if you notice these other fields down here, user form field, password form field, submit button, those are because most of our customers are using our DAS capabilities with SPA, single page applications. And even though we are going to this authentication URL to log in, it may be that there are specific fields or buttons that need to be completed on that page itself, or certain buttons that need to be clicked to submit the information. And that's where those fields can be captured. Okay, for our demo purposes, we're good enough. We can save off that profile. And there is the ability to scan these. Remember, Rose had one example of secret detection, which would run on a scheduled basis. We can do that with our DAS scans as well. And again, this is the on-demand one. For our case, we'll just save this off. and consider it done. Okay, now if you were to actually run this, you can imagine what's going to happen. It's going to go ahead and do a passive scan against um, the endpoint that we had specified. You can create a whole library of these if you wish and launch them by simply doing run scan. Okay, so that's really it for configuring a on-demand dash scan. I will briefly bring up some historical runs that we have done in the past. All right, so you would be able to go to any of these and even click on view result. That one looks like it ran into some kind of error. Endpoint might have been missing. It's the most common thing, but we'll look at one that successfully ran, right? And you will see findings as they showed up in a vuln report in all of the other previous exercises. All right. Let's go ahead and move on to exercise 2 here. The audit events. So we've been configuring some fairly heavy duty things, right? Policies that apply to all of our projects, or at least one project in our case. So where's that configuration activity being monitored? Let's go ahead and click on Secure Audit Events, right? And you can do that from anywhere within your Tanuki Racing Security and Compliance Workshop project. I will stick to best practice and navigate back to my group and navigate back to the Tanuki Racing project. And let's go to Secure. Let's go to Audit Events. And what you see is, well, there's some familiar looking activity, right? A DAST scanner profile, site profile, and overall DAST profile was added. We added a license policy, right? My timestamps, I did this last night in preparation for the workshop. So we can see that where we added Logan Stucker to approve changes, that's also captured as well. So this is a subset of the audit events that GitLab will capture. I am able to see it because I have the proper permissions, but of course, not every single role within GitLab will be able to. Okay, so be aware that's at your fingertips under secure audit events. And there's a whole lot more of them that are laid out in the documentation. Okie doke. We've configured the scanners using policies by including templates, right? But I did want to call out that there's a UI-based way to configure scanners as well. It's via secure-security configuration. So we'll explore the 4 steps of this lab as far as what UI-based configuration would look like. So again, we're going to secure. We're simply going to security configuration. That is the last option at the bottom. And had I wanted to, I could have easily said, let's just go configure SAST from this interface, and a wizard will show up and allow me to configure it via a merge request. Okay, so be aware that this capability does exist. It allows you to specify things like the Docker image, what paths you want to exclude from static analysis, right? What stage in the CI pipeline does this SAST job run under? I'm going to hit back one time. One other thing that's pretty easy to miss in security configuration is vulnerability management. And that's where you'll be able to see our training partners and be able to toggle them on and off if you wish. Okay. That is actually the big stuff for extra scanner configuration. Now you might be wondering, hey, we haven't clicked a whole lot in this lab. Here's where we'll actually interact with some code, right? 2 final exercises to go. And we're going to go ahead and just zip right through them. Let me check the chat real quick to see if there's anything I need to address. All right, looks like the team's helping out, so appreciate y'all. All right, step 4, code owners. Let's work through this one. Code owners is a very special file in GitLab. It's a marker file, right? When GitLab sees code owners in the root of your repository, it'll say, I know which individual owns what code and who to prompt to review changes to whatever they own, right? Typically, that's going to be a file or a type of file. All right. So in that spirit, what we're going to do in this lab is we're going to use the web IDE, and we're going to add a code owners file, which I'm copying to my clipboard right now. And one key thing here is when we create the code owners file, the second line says at GitLab underscore username, please replace that with your own GitLab.com username. Okay? Because what we're going to say there is we're going to make yourself the owner of any file that has the extension gemspec. For the line down here that I've got highlighted, where it says the owner of README is LF Stucker, that's Logan Stucker, we will leave that alone. Okay, we do want Logan to continue owning the README, but we want to make each of ourselves, our GitLab.com accounts, the owner of the gem specs. All right, let's go ahead and just go through the exercise. And by the way, at the end, one thing we are also going to do is I will highlight the sentence. We're just going to commit this straight to main. I'm bad with the mouse today. You see this sentence. We're going to commit the change straight to main, okay? It save ourselves a little bit of time. So let's take care of business. Let's go back to our group. Let's go to Tanuki Racing Security and Compliance Workshop. Going to go to Code and pull up the Web IDE. I'll close out one of my browser windows to minimize the number of tabs. And go ahead and right-click anywhere in the Explorer and make a code owners file, just as you see here. Okay. Going to paste in what we copied as far as the code owners. And here's the change I'm going to make. YHSUEH is my GitLab.com username. And on line 2, do be sure to put @ in your GitLab.com username. All right. Once that's done, we will abide by poor practice for the purposes of the lab and simply commit straight to main. Okay. Committing to main on purpose will be my comment. Let's go ahead and push. Click Go to Project for a quick, easy navigation. And we'll give that pipeline just a second to run. All right. So what we're doing here is we are saying, again, that any changes to a .gemspec file require whichever user was specified, in that case, that's myself, needs to review that change. And Logan needs to review the README. All right. So we're going to see if that's actually happening in just one moment. Let's move on to step 5 for right now, while that pipeline is running. So what I want to do here is actually, I'll highlight it, start with steps 1 and 2 of, steps 1 and 2 of the license compliance and code owners in Action Lab. All right, because there's a setting that we want to turn on to make sure that code owner approval is enabled. Okay, so where is that setting? Going back to your Tanuki Racing Security and Compliance Workshop project, if you go to Settings on the left-hand side, from there, go to Repository. Expand branch rules. And for your main branch, click View Details. And turn on Require Code Owner Approval. Right? I know that's quite a few clicks, so I'm going to just go through it one more time just to make sure that I don't lose anyone because it is important. For our code owner approval gate to work, what we did just there to enable code owners, aside from creating the code owners file, that is we went to our Tanuki Racing Security Compliance Workshop project. We went to settings in the left-hand side, went to repository, we went to branch rules, found our main branch, did view details, and enabled the code owner approval. Okay. Reason I wanted to really take my time and be deliberate here is this button has changed locations since maybe 6 months ago. Okay, so if you're used to finding it elsewhere, this is its current location. All right. Now that we've got require code owner approval set up, we can go ahead and return to Tanuki Racing Security and Compliance Workshop. Okay. Looks like that pipeline is moving along. What we want to do next is the actual code change. Okay, so this one is going to take, we're going to make 2 changes here. We're going to do it in the web IDE. So let's focus on, and I know it can be a little bit tough to follow when I'm going back and forth between tabs, so I'm going to try to minimize that to the extent possible. We're going to focus on steps 3 and 4 right now. All right, so what we're going to do is locate a file called tanukiracing.gemspec. And we're going to insert the line that I'm copying to my clipboard before line 22. So in essence, this is going to be the new line 21 is the other way to think about it. Okay, so let's go ahead and do that. Let's go ahead and do steps 3 and 4. All right. We are going to go to our handy dandy web IDE again. I'll close out my previous tab. And we're going to go to tanukiracing.gemspec. Should be way at the bottom of the Explorer. And if you've got that line of code from the lab instructions, that was step 4 is where the line of code came from. Yeah, I guess I was wrong. It's new line 22. Okay, so this is the line. This is the code as I found it. I'm on line 21, give out a carriage return, and make that the new line 22. You may see that Duo is trying to suggest code. Go ahead and ignore it for the time being. All right, so that's the first change. The second change is going to be step 5. We're going to add some dependencies. So I'm going to go ahead and copy the code from step 5 to my clipboard. And the file we're going to work on is called gemfile.lock. We're going to replace the dependency list. Let's go ahead and focus on step 5. Okay, so if your web IDE is still open, we will find the file gemfile.lock. Got it right here. What is that? That's the 6th file up from the bottom. We can go and wipe out the entire dependency list there and just replace it with the easy peasy list that we've provided in the exercise. All right, now keep your web IDE open with those 2 changes recorded. And let's go ahead and scroll past the big old dependency list and see what we're going to do here. Now we're going to go through and I'll just highlight them all. Steps 6 through 7. Okay. You all have gone through these steps several times in the labs earlier, so they're going to be pretty darn easy. Basically, create a new branch, commit to the new branch, and get your merge request, right? And this is the final lab. So I'm going to go ahead and go through it live. All right. Going to go to my handy dandy source control button on the left-hand panel. Final workshop exercise or whatever comment you like. Hit that little drop down, create a new branch and commit. Just hit enter. I'll accept the branch name. And we're going to get our create MR button in the lower right. We'll hit that puppy, get it set up. All right, let's go ahead and uncheck delete source branch when merge request is accepted, we do this so it hangs around in case anyone needs to, go back and do a step over. And other than that, that should really be it. Let's go ahead and hit create merge request, excuse me, when you're done. And you should see a pipeline fire off. Okay. And that's actually the final pipeline that we will be kicking off for this exercise. Because what have we actually done in lab 3 and lab 4, right? We set up a license policy and we have changed some dependencies here and we've added a code owners file. So we should expect to see some code owners be prompted for approval. And we should be able to see if we have a open source component with an LGPL 3.0 license, that should come up and say, hey, there's a license policy against these. Is this something that you really want to introduce into your code base? We'll give it just a few moments to wrap up. How about we take a quick, maybe 2-minute break and come back at 45 after. Go ahead and leave it on the screen for the time being. All right. I'm going to go ahead and just pick up. The pipeline should have finished running by now. So do have a look at the merge request. Give it a quick refresh if you wish. Okay, what you should be seeing happening here is a approval, right? Remember the merge request approval policy, which I call MRAP for shorthand, that Rose helped you all configure earlier. That's still in effect. Logan Stucker is being asked to approve. But our license policy also kicks in and says, well, hey, wait a second, there's an LGPL 3.0 license. Let's make sure we get approvals to actually introduce that. Now, what's interesting is Logan's being asked to approve a change because we changed something that he was a code owner of, right? Well, who's the code owner of the gem spec file? In that case, that's myself. In you all's case, that's your individual user. That approval is going to come up as optional, okay? And the reason for that is when you are the owner of the code and you are submitting the MR, you're kind of exempt from approvals. All right. So I just wanted to throw that exercise in there to make it very clear how code owners' approvals actually works in practice. And that should be the final merge request to wrap up the lab. hopefully everybody was able to get this result. If not, as we mentioned at the top, this lab environment will be around until October 22nd. So there's actually 3 times the normal amount of time. And we are around to help as well with individual questions. What I'd like to do at this point, all right, you all can close the issue in celebration. I'd like to turn the presentation back to Rose to take us home on the final track with live Q&A at the very end. So Rose, presentation is yours. Hopefully I didn't ruin your good work.
Okay, great. Thank you so much, Richen. And I hope everyone was able to follow. And as Rich mentioned, we wrapped up lab 4 and well done. And so we do have one optional lab to transfer the project. So if you would like to retain your work and you would like to use it as a reference, you can migrate, basically transfer the project into your own GitLab account. And yeah, let me share my screen here. As I mentioned, this lab, it is optional. So we will go over how you can move your project into your own namespace in order to review the content once the group has been deleted. We will keep the environment up and running for you all until October 22nd. So you do have some time to, if you haven't finished all the labs, you do have some time to catch up. And so a warning. So before you transfer the project, because with the lab environment, we gave you all dual enterprise access, GitLab Ultimate access. So once you transfer the project into your namespace, right? It depends on you if you're using your personal namespace or work related. So you might lose the access to some of the capabilities, like with the security and the compliance user cases we went through. Most of them are part of Ultimate. And so just wanted to give you all a heads up on that. And if you are interested in transferring the project into your own GitLab namespace, there is instruction in the same project, the main project. If you go to Tanuki Racing, click into courses, and there is a markdown file for transfer instructions. So let me switch my screen. So basically, as I mentioned, go into the transfer project. There's a markdown file for all the steps you need to follow if you would like to transfer the project. It depends. So there are 2 options. If you would like to transfer just one of the projects, maybe just the main project, because that is basically most of the contents is, and also the setup you have, right? But if you're interested in transferring the whole group, you can do that as well. But for this hands-on lab, we're going to work on transferring the main project. So what you're going to do, make sure you click into the Tanuki Racing workshop project. And let's see, projects cannot be transferred when there are images in the container registry, and we need to clean them up by going to deploy. So because we did build the application and push the images, so we need to make sure we're going to go to deploy and go to the container registry. We do have a few images. So we're going to just remove those images, like the trash can. Okay, we do need to confirm it. All right. If you have a multiple, just go through the step and remove the images. All right, so, okay, here. All right, So all the images are scheduled to be deleted. So once we have that step done, now we are going to the project setting. So this is for transferring the specific project. You can also transfer the entire group. So go to the project settings and go to general. So we are already on general. And if you scroll all the way down to advanced, so this is where basically the actions you can do on the project, exporting the project or renaming the path or transfer the project. So we are going to go all the way down to the transfer project section, okay? And then, so basically what we're going to do, just locate the transfer project section and click the select a new namespace drop down. Make sure you are going to select your namespace, okay? Let me see. I'm not going to transfer, just show you the process because I already have the project in my namespace. So basically you just look up your namespace and make sure it's the correct one and then select that one. And once you select that one and click on transfer, then it will transfer the project into your namespace. But I feel like if you're not done with all the labs, I would recommend like not transferring right now. Just remember, you always can go back to the instruction, the MD file, to follow the steps to do it. And yeah, so the other option is transferring the entire group. So if you want to retain all the projects we created as part of the workshop, just go to the group and go to the group settings. Similarly, go to advanced, and you will see the option transfer group. So now here you are going to select the parent group. So you can enter and look up your group and then transfer the group into your namespace. I think that wraps up the transfer project lab. And now we open it up for Q&A. Thank you so much for joining with us today. If you have any questions, feel free to put them in the chat box or verbalize it.
Okay, doesn't look like we have any questions coming in. Give it just one more minute, and then we can go ahead and wrap up. Nope. Okay. All right. I don't think we have any questions. So thank you everyone for attending. And thank you to our wonderful presenters. You guys did an amazing job today. Just a reminder, the recording and the slides will be sent out to everyone via email. And again, as mentioned before, you guys will have access until October 22nd. Just a quick shout out, our next workshop is project management. It'll be a hands-on workshop on November 6th. So if anyone is interested in registering for that, that is live on our GitLab events page. So you can go ahead and register for that. And I think that is everything. Yeah, I don't see any questions. So thank you everyone for being here, and I hope you have a great rest of your day. Bye.
Thank you.